So this next section is about specifications and installation methods. Here you can see a whole bunch of different changes over the last 9-10 years in the specifications of heat pump water heaters, and I wanted to go through them so you can understand more about how they work and how they get sized and etc. So starting over on the left-hand side, that green box up on top, it says the first hour rating. That's a Department of Energy standard test. It's run at 3 gallons a minute, which is more hot water than most people are using these days with efficient appliances, but nonetheless, very conservatively. 3 gallons a minute, you just run the tank at full blast until it runs out of hot water. That's the first hour test. How much water can it deliver in the first hour? So you have 56 gallons and 67 gallons back in 2011. If you look at the bottom, the green box sort of in the middle, you see 60 and 67 gallons, a little bit more for the first tank type, 40 gallons. And down below it, that's an example of a lower power heat pump water heater. So they went from 4,500 watts down to 2,250 watts. And you see its first hour delivery is 46 gallons and 54 gallons. That's the result of having less electric resistance back up in there. So when that first hour test is going and you're running at full blast, the electric resistance is doing some of the water heating work. If you have less power to the device, it has less ability to make up that hot water. So going back up to the top, you see in 2011, in the blue box, the recovery in gallons per hour at 90 degrees Fahrenheit rise. So say from 50 degree Fahrenheit water outside up to 140 degrees inside. Though it's inside the tank. That's a 90-degree span there. So it can do 21 gallons of recovery. If you go over to the 2020 specifications, that blue box at the very end, it says not 21 gallons, but 26 gallons and 27 gallons for the same power demand. This is about its efficiency. This is what happens when you get a heat pump water heater with a better and better compressor over the course of 9 years, is it can do more and more work of heating hot water. The electric resistance elements didn't change. That's the compressor doing more work there. However, you can see down below that once you get rid of a good deal of the electric resistance, that recovery drops down to 16 gallons per hour. Not a whole lot. Next one over on the top is you can see in yellow the energy information. So you see it's an energy factor 2.0. That's the federal minimum efficiency. You can't make one that's worse than that. And that's what was being made by Rheem back in 2011. And you see its cost to operate is $234 next to it. You go down below the yellow boxes, instead of an energy factor 2.0, it's 3.75. Dramatically more efficient at getting the air heat into water heat. And the cost, of course, drops from, say, $234 down to $104. Note that the one that uses less power, that has $78 per year cost. That's the lowest of them all because it's using less electric resistance, which is a more expensive type of electricity. 3 to 4 times as much electricity is going to get used with the resistance elements compared to the heat pump. Now, a couple other things that weren't listed in the original spec there, but you can see in orange the 4,500 watts that's used in the 2020 model versus the 2,250. Those are 2 different products now offered by Rheem. So here you can see another specification sheet, and I wanted to show you some details from it. The Stiebel Eltron is the one that started being manufactured in 1985 and is still being manufactured today. And it's interesting, they've got kind of sophisticated in their specification sheet. They give you information that other manufacturers don't. So as an example, the maximum domestic hot water temperature, that's 149 degrees Fahrenheit with this product. The other manufacturers will generally list it as 140 degrees Fahrenheit. They can actually go up to 160, but they don't tell you that. And frequently the tank is fixed at 140. But Stiebel Eltron goes up to 149. The reason why they do that is because if you have less recovery ability, if your heat pump water heater doesn't have the ability to produce a whole lot of hot water over time, it's better to store it. Just to have it on demand when you need it, as opposed to relying upon electric resistance to make up for the deficit. Instead, just plan ahead, have more hot water there because you've raised the temperature. And of course, put a mixing valve on it. In SMUD territory, putting in a new heat pump water heater requires a mixing valve, so this is standard. So you can go from 149 degrees Fahrenheit stored down to the standard delivery temperature of 120 Fahrenheit. This product also, it speaks to the maximum available water at 104 degrees Fahrenheit. Interesting specification. People don't usually ask what is the amount of water at 104 degrees Fahrenheit. The reason why they show that temperature, though, is that that's the temperature that people shower at. They might have water stored at 120, but they actually mix it down to 104. So what Stiebel Eltron's trying to say here is that if you have one of their 58-gallon tanks, it can actually deliver 106 gallons of shower temperature water. Or if you have one of their 80-gallon tanks, it can deliver 147 gallons of shower temperature water. And that's what people mostly want is showers. And that tells you if the average shower is maybe 8 to 12 gallons of hot water being used and then mixed with cold, you might have 8 to 12 showers you can do with this tank and reassure people then that they're not going to run out of hot water from showering. Well, let's look at the next specifications, the heat up time. So if it's 59 degrees Fahrenheit outside, it doesn't take as long as when it's colder. So you see 6.98 hours to 8.7 hours of time to heat up the whole tank if it's completely drained and cold. Whereas when it's colder outside, it takes longer, 10 hours to about 12 hours to heat up the whole tank. Once again, it's best to store the hot water ahead of time as opposed to relying upon makeup. Then if you go down below, you can see they're 220, 240 volts, of course. But notice that this product, built since 1985, only requires a 15 amp circuit breaker. This is an example, like I showed you previously, of a lower power product. It still requires 240 volt electricity, but about half as much as some products that require, instead of being 2,250 watts, it's 4,500 watts. So you might have the question of, how are residential heat pump water heaters sized? Well, I mentioned before that there's a first hour rating. That's running a water heater out at 3 gallons per minute, which is a little bit less than what a bathtub is using, but maybe 2 showers running at the same time if they're efficient showers. And there's a calculus. You look at the number of bathrooms in the house, so you could have coincident showering. And you look at the number of bedrooms in the house, so you can figure out approximately how many people live there. And then you can see below the first hour rating that best matches that combination of bedrooms and bathrooms. And it goes one bathroom and one bedroom, just a one bedroom home, 42 gallons. That's the maximum people pretty much need. And that will cover 99% of the households that are of that size, of that number of bathrooms. And it goes up to 54 gallons with both 2 and 3 bedrooms. And then you see if you have 2 to 2.5 bathrooms, it starts at 54 gallons with 2 bedrooms, and it goes up 67 gallons and 80 gallons. And you can see again, as you get more bathrooms and more bedrooms, the range basically is from 42 gallons up to 80 gallons. And once again, capturing 99% of all the usage behavior you'd see out there. The importance of sizing correctly can be seen in this graph. And also considering how to set the temperatures and the controls. Those are all related there. So in this situation, you have households that both have access to a 50-gallon heat pump water heater. And on the top, you're seeing what one occupant might use. And on the bottom, you're seeing what 5 people might use. This is real-world data, but average for those number of bedrooms and people. So up on top, that pink color, that's the electric resistance energy that's being used. And keep in mind, that amount of energy, in order to get the amount of heat out of it, you're using 3 to 4 times as much electricity when you're using electric resistance compared to the heat pump. So that electric resistance energy there isn't getting a whole lot of work done, but thankfully it's not being used that much. It's backup energy. What we're seeing is that this person is not using that much backup energy. But look down below, you see these huge spikes. This is a significant amount more electricity that's being used. But it didn't have to be that way. If this water heater had been set to 140 Fahrenheit and set just in heat pump only mode, get rid of the whole red, what we've found in field studies is that would work. 99% of households would be happy with a heat pump only mode, so no electric resistance to be engaged, just stored at 140 Fahrenheit instead of 120 Fahrenheit. And that gets them through 99% of the usage events out there. So this is a big deal. When you're installing heat pump water heaters, you have to put in a mixing valve because that's SMUD requirements for the rebates. And then you can set it to the heat pump only mode, which produces the lowest bills for people and also makes it easier for SMUD to balance the grid because they don't get these big spikes of electric resistance coming on in the morning and the evening. So now let's talk about the energy impact of ventilation. These are real-world examples. These are developments that put in heat pump water heaters back in 2014, and then my company studied them. We monitored them second by second so we can make some of the pretty graphs and really understand what happens if you put a heat pump water heater into a little unvented closet versus if you give it access to all the air that it wants in a garage. So up on top in the orange, you can see at King City, which is an unvented closet installation. If you have one bedroom, you're using about 5.1 kilowatt hours a day. But down below, that same one bedroom apartment in Dixon, that's in a garage, and it's using 3.6 kilowatt hours a day. Go back up top, and you can see a 3-bedroom is using 7 kilowatt hours a day in King City in an unvented closet. Down below, 3-bedroom apartment, it's 5.5 kilowatt hours a day. So essentially, if you have a garage, your heat pump water heater can use as much energy in a 3-bedroom as you'd use in a 1-bedroom of unvented. Those two are equivalent. So it's obviously better to put it into a garage or into a vented closet, or grab air from the attic and bring it down with ductwork so it's feeding off of really hot air up from the attic. There's a lot of different installation strategies I'm going to show you in just a moment here. If you're putting it into a house, you have options. It needs to be a 700 cubic foot room. So that could be like a pretty significant pantry, or it could be just like the laundry room or something like that. Now, over to the right there, you can see that if you put it in with a vented door, you can put it into a small closet. You don't have any space issues to consider because it's essentially connected with the air around it. If you want to have a door that's not completely louvered, then you can undercut the door by about 3/4 of an inch and put a little bit of louvering up top. And that's a really simple, easy installation. You can also duct them. So they come with little duct kits. They can run about 12 feet without a booster fan. And then you can pull air from kind of anywhere you want, and you can deliver it to anywhere you want. A lot of flexibility with using ductwork. One of the things to think about, though, that's different about a heat pump is that because it's chilling air, it's making condensate. There's a little dribble of water that comes off of a heat pump water heater. And you need to plumb that somewhere. It can just go to the ground if necessary, but it's best to put it into a drain. So you might have a floor drain, or it might be next to a washing machine. You can put the drain into the same common sewer line. And it's not ideal to have to pump it up. It's really best just to use gravity so the product works the best it can. If you are looking at having a larger power heat pump water heater, but you don't want to increase the size of the service, you don't want to do any complexities to the breaker panel, you just want a higher power heat pump water heater because maybe you've got a really big family and you want to have a full 30 amps of power to back up. You can do that. You can put in a plug into the dryer outlet plug, assuming you have one, or that outlet could be shared with the 240 volt outlet for your stove, or potentially for a car charger. Any of those 240 volt plugs can be shared with a heat pump water heater. This is an example of a product, the NeoCharge, and there's 4 or 5 others. They will take that plug energy and split it between the two appliances. You can have one plug be the sort of subservient and the other one being the master, and the master one will always get to turn off the other one. An example would be if you're cooking food on the stove, you need that to happen and work while you're using the stove. So you're not going to turn off the stove. But a water heater has a lot of energy stored in it. So if you're cooking for 20 minutes, you can essentially turn off the water heater. No one will notice. And then once you're done cooking, the water heater turns back on. And that way, you don't have to put in a new plug or a new power supply or any of those kinds of things. You can just use the existing plug as it is. To summarize, you'll generally need 240 volt electricity. You do need access to air for your heat pump water heater for it to work efficiently. If you don't give it access to air, it'll work inefficiently. It'll still work, but it'll use a lot more energy. And you need to be thinking about, where does the condensate go? So let's take a few minutes to talk about the client benefits of heat pump water heaters, why they might install them, and some things you can chat about while you're working there. You can start off with that heat pump water heaters are generally less expensive to operate in a person's home. That's true nationwide. You can see here, these are two yellow tags off of a heat pump water heater on the left, and the very best of the gas water heaters over there on the right. And you can see that it costs significantly more per year to use the best gas water heater that's available in the country versus one of the best of the heat pump water heaters available. That's true in Sacramento as well. You can see here two different rate schedules that SMUD offers. The first one is the time of day schedule. So over the course of a day, the utility rate changes, starting at about 10 cents a kilowatt hour, going up to about 15 cents a kilowatt hour, and then dropping back down. Then in the summertime, different schedule, still inexpensive in the morning, off-peak hours from midnight to noon, but then it gets more expensive after noon, all the way up to midnight, and particularly in the 5 to 8 p.m. time. What's great about heat pump water heaters is that they can be scheduled. You can have them turn down the temperature so that they don't activate the electric resistance elements in those peak hours until they get to, say, 115 degrees Fahrenheit. Or you can put them in heat pump only mode and run them at 140 Fahrenheit. Because remember, they have that thermal mixing valve, so it's safe to operate them that way. And that way they have enough capacity, and then maybe only turn on the electric resistance element when it gets down to 115 Fahrenheit. These kinds of strategies can make sure that people can operate their heat pump water heater when the cheapest electricity is available, and then consistently beat the operating cost of running even the best gas water heater. Another type of rate schedule is called fixed rates. So it's a little bit more expensive during most of the year than it would be just in the morning time under the variable rate. Now it's 11 cents. And then in the summertime, it's consistently more expensive at about 18 cents a kilowatt hour, regardless of the hour. So that makes it more expensive than some of the hours that are available in the time of use rate, but you at least know what you're up to, and you can invest in efficiency and just keep your overall bills lower. And that's still, at 18 cents a kilowatt hour, less expensive than most of the electricity sold in California. The Sacramento Municipal Utility District does have some of the cheapest electricity available in the state of California. And then there's the issue of safety. In the United States, 500 people die a year from carbon monoxide poisoning. Gas water heaters are a significant contributor. Here's an example. Anna Faris, you might recognize her from Scary Movie 3 and other scary movies. Well, the scariest experience of her life was her whole family nearly died while they're all on vacation in a skiing chalet. And the gas water heater had a leak where the combustion pollution was being vented out. And instead, it vented into the place they were staying. And they got poisoning, went to the hospital, survived, but a terrifying experience. If you live in Sacramento, you're concerned about smog. It's one of the issues that people who live in Sacramento struggle with because they have some of the worst air quality in the country. Here you can see a picture of smog in 2003. Here's another picture of smog in the spring of 2019. This has been a problem all the way back into the 50s. We have some of the worst air quality in the country. Gas water heaters contribute as much to smog as about half of the cars that are on the road in Sacramento. It's that bad. If we can get rid of these gas water heaters, it's a significant benefit to everyone who lives in Sacramento. Here's an illustration from a great study by the Sierra Club, where they showed how the air pollution contributions of a heat pump water heater were an improvement in every single state in the United States, even running on the grids that have 90% coal in them versus the grids that have, say, 50% renewables like California does. Doesn't matter what state you're in. Because a heat pump water heater collects so much energy from the environment as opposed to burning it, because so much of the energy is essentially just heat from the air, it doesn't matter how dirty the electricity is. Even if it's nearly 100% fossil fuels, it's still a climate benefit. It still reduces greenhouse gas emissions if you run a heat pump water heater compared to the very best of the gas water heaters on the market. There are three big benefits. Heat pump water heaters in Sacramento cost less to operate. they're significantly safer, and they cause less air pollution. I want to thank you for taking this course. I hope you enjoyed it, and I wish you the best of success electrifying with SMUD.